Good morning, viewers. Today we'll be looking at physics. The topic is equilibrium of forces. Equilibrium is a state of an object with respect to a given observable quantity during the time for which there is no change in that quantity. An object is in equilibrium when it is not accelerated, that is, there is no net force acting on it in any direction. Bodies at rest are said to be in static equilibrium when a body moves with a constant velocity in a straight line, or when it is rotating with a constant angular velocity about a fixed axis through its center of mass. The equilibrium is said to be kinetic or dynamic equilibrium. The resultant force is that single force which, acting alone, will have the same effect in magnitude and direction as two or more forces acting together. The resultant force is found by the parallelogram law of vectors. Now also look at the equilibrant of two or more forces. They said is that single force which will balance all the other forces taken together. It is equal in magnitude but opposite in direction. So take note of these two definitions, resultant force and equilibrant. And also we are told that bodies at rest are said to be in static equilibrium, and then the body's in motion is said to be in kinetic or dynamic equilibrium. That is when a body moves with a constant velocity in a straight line, or when it is rotating with a constant angular velocity about a fixed axis through its center of mass. The equilibrium is said to be kinetic or dynamic equilibrium. Okay, and they say two forces 10 Newton each are inclined at 120 degrees to each other. Find the single force that will, Roman figure 1, replace the given force system. Roman figure 2, balance the given force system. Alright, let's solve that. Okay, two forces 10 Newton each are inclined at 120 degrees to each other. So this is what it means. First, you have something like this. Now 120 degrees will fall on the second quadrant. In the first quadrant you have 90 degrees. Second quadrant is 90 plus 90, which is 180. So 120 degrees will fall on the second quadrant. Okay, so it falls on the second quadrant. Alright, so it falls here. So my angle now is 120. Okay, and then the force, so the two forces are 10 Newton each. Force here is 10 Newton. The second one, draw the second force. Second force is 10 Newton as well. Alright, so I'll use dotted lines. Then to represent this other one, I also use dotted lines. Okay, so the resultant now, we move from here. This is my resultant. That's the resultant, and the direction is theta, or you can say alpha. Direction is alpha. Then the equilibrants will balance the given force system. The equilibrants will balance the given force system. So the resultant replaces the given force system, that is these two forces. The resultant replaces it, and we use the parallelogram law of vectors. The equilibrants will balance the given force system. So I can call this center point. I can call my center point point O. Then I call here A. call here B, call here C. Okay, O A B C. All right. So if I extend this line, and then this, since this side is parallel to this side, and this side is parallel to this other side, this angle will also come out here. I mean, here is also 120 degrees. This angle corresponds to this angle. They are corresponding angles. So that means this other smaller one now, we'll find it. That is, if you cut out this section, 120 degrees, and here is unknown. I can call here theta. You want? So it means that this is theta plus 120 degrees equals to 180. Sum of angles on a straight line. Okay, so it means that theta will be equals to 180 minus 120. When you take this one over here to change to negative, so theta will be equals to 60 degrees. This angle is 60. So the angle at this point is 60 degrees. That is it. 60 plus 120 gives me 180. That's sum of angles on a straight line. Okay. Then I will then cut this section of the triangle. I will take triangle OAB. I'll cut this triangle out. Cut it out, and I'll have, see, from triangle OAB, I'll have something like this. This is O, this is A, and this is B. Okay, angle here is alpha. The angle here is 60 degrees, and then this is 10 Newton. This side is also 10 Newton. Reason being that this is parallel to this, so line CO is parallel to BA. That means 10 Newton is 10 Newton here, and 10 Newton is also 10 Newton here. OA is parallel to CB. Okay. Alright, so this is my resultant. I'll find the resultant. Now, if this is capital O, the side that faces this angle here is small o. This is capital A. The side facing this angle at A is small a. Capital B, the side facing this is the side facing capital B, will be small b. Alright, so I will use my cosine rule. So using cosine rule to obtain R, the resultant. Now this will be, I will say, cosine rule now will be a square equal to b square plus o square minus 2bo cos. Now since I'm looking for a, the angle will be at point A, cos capital A. Okay, and small a is my resultant, the resultant arrow. Okay, that is arrow. This will be arrow square equal to small b is 10. That's 10 raised to power 2 plus small o is also 10 as well. That is 10 raised to power of 2 minus 2 times 10 times 10 cos. Now angle at A is 60 degrees. Okay, that's cos 60. Alright, and then I'll be having that arrow square r square is equals to 10 square is 100, and 10 square is also 100, minus 2 times 10, 20 times 10 is 200. 200 cos 60 is 0.5. Okay, so when I add this, 100 plus 100 will give me 200. So r square is equals to 200 minus 200 times 0.5 is 100. Okay, 200 times 0.5 gives me 100. So 200 minus 100 will give me 100. So r square will be equals to 100. I'm taking the square roots. R will be equals to square root of 100, which is 10. So I've obtained my resultant, magnitude of the resultant as 10 Newton. Now the equilibrant will counterbalance the resultant. Equilibrant counterbalances the resultant. So you say equilibrant E is equals to R, it counterbalances resultant, means that E is equals to 10 Newton. Okay, so E, my equilibrant, will balance the given force system. You see, the force that will balance the given force system is the equilibrant, and the one that will replace the force system, these are the forces. The system of forces are 10 Newton, 10 Newton. The one that replaces the force system is the resultant, and we had the resultant as 10 Newton. So we must know that the equilibrant counterbalances the resultant. That is all you need to do there. Then if you choose to find the direction alpha, if you choose to find the direction, how then do you find the direction? Using sine rule to find the direction alpha. So use sine rule to obtain the direction. To obtain the direction alpha. Okay, so let's use sine rule and find the direction. Alright, so we'll come back to this diagram. Now using sine rule now, this will be sine A over small e equals to sine B over small b equals to sine O over small o. Now we're having sine A over small e equal to sine B over small b is equals to sine C over small c. Alright, okay, so what we are looking for now is the angle at O. So we have angle at A, we neglect that of B. So angle at O is alpha. This is sine sine A over small a will be equals to sine this is O, not C, rather sine O over small o. Will be equal to sine O over small o. Alright, so the angle at A is 60 degrees. If you observe, that's 60 degrees. So this now will be sine 60 degrees over small a. Small a is my resultant, and we had the resultant as 10. That is over 10 equals to sine. Angle at O is alpha. Angle at O is alpha over small o is also 10 Newton. Observe that small o is 10 Newton. So over 10. Okay, so you see that this, when you cross multiply, we having this is 10 sine alpha is equal to 10 sine 60 degrees. Okay, and then you'll be having sine alpha is equals to 10 sine 60 over what? 10. You divide by the coefficients, divide by 10. So this will cancel out this, and sine alpha will be equals to sine 60 degrees. It implies that sine alpha is equals to sine 60 is 0.866, and that alpha will be equals to the sine inverse of 0.866. It means that alpha will be equal to is equals to 59.99. Using your scientific calculator, you have something like this. Then when you approximate it, this is approximately 60 degrees. 60 degrees to the nearest whole number The principle of triangle of forces. The principle of triangle of forces states that if three forces are in equilibrium, they can be represented in both magnitude and direction by the three sides of a triangle taken in order. So let's look at this example. They say the mass of 2.0 kilogram is supported by two cords which make angles of 30 degrees and 50 degrees with the vertical. Calculate the tension in the two cords. So let's assume that this is the mass. This is a mass. And then it is supported by two cords. This, first of all, we should know that this mass has its weight, and the weight of this mass will act vertically downwards. So the weight is mg, and the mass was given to us as 2 kg. The mass was given to us as 2 kilogram. So we'll convert it. This is W. W now will be equal to 2 kg times 10 meters per second square. This is 20 Newton. So the weight is 20 Newton. Okay. Now they said it was connected by two cords. So at this point, let's say at this point, two cords were holding it. These are the two cords, and each of them are inclined at angles to the vertical. They are both inclined at angles to the vertical. So these are the two cords, angles of 30 degrees and then 50 degrees to the vertical. So we're having something like this. So tension is acting in these cords, tension T1, and tension is also acting here. Call it tension T2. Okay, so that is it. It said a mass of 2 kg, that's the mass. We have converted it to weight, and the weight of that body is mg, mass times acceleration to gravity, which will be 2 times 10. That will be 20 Newton. Okay, then they said it was supported by two cords which makes angles of 30 degrees and 50 degrees with the vertical. So chord 1 makes an angle of 30 degrees with the vertical line, chord 2 makes an angle of 50 degrees with the vertical as well. Find the tension in the two cords, that's tension T1 and the T2. So we'll use the triangle of forces in solving that. So the first thing now I'll first take my weight which is acting vertically downwards. So if I take the weight, so taking the weight that is acting vertically downwards, I have something like this. The weight of the body that acts vertically downwards is this, that's W, which is 20 Newton. Okay, so the next thing, I'll come back to this diagram. If this is 30 degrees, extend this line. So this is 30 degrees, here is also 30. Why? They are alternate angles. Okay, and you should also know that 90 minus 30, here will be 60 degrees. So this side now will be 60. So this will alternate this will alternate this. And then what will you say about this other side as well? 90 minus 50, here will be 40 degrees. Okay, so this will alternate here as 50, then 40 will also alternate this side as 40 degrees. Okay, alright, so then I'll take this tension T2 going this way, take that tension. So I'll take tension T2 going like this, tension force T2 inclined at an angle 50 degrees. Okay, inclined at an angle 50 degrees. That's this tension force T2. You see that the angle here is 50. This is the angle I took. Then I'll then take this other one going like this, keep that one going like this. And also observe the angle there. Take this angle 30 degrees, so this will go like this. I'll come back here, I'll join it here at the head of this. Okay, call this tension T1, and the angle there was 30 degrees. Okay, so that is it. That is a simple diagram. This angle outside is 40, and this is 30 degrees. That means here will be, this angle here will be, that's 90 minus 30, you have 60. Here is 60 degrees. So this angle will alternate here at 60 degrees, and this 40 degrees will alternate here. Angle 40 will alternate here as 40 degrees as well. 40 degrees, okay? Alright, so then I'll add it. 60 plus 40, that gives me 100. Gives me 100 degrees. That's the angle at that point. Okay, while the angle at this point is 50, angle here is 30 degrees. Here now will be 100. Okay? So this is my tension T2. And this is tension T1. Alright, we'll solve for each of them. You can call this strategic point A. Call that point A. Then call this point B. And call this point C. Okay? If here is capital A, this side facing capital A becomes small a. Here is capital B. The side that faces this B becomes small b. Here is capital C. The side facing capital C becomes my small c. Okay, so for capital A, the side facing it is small a. Capital B here, the side facing this angle at B is small b. Capital C, the side that faces it, that is directly opposite to this, is this side, which is small c. I will use sine rule. So using sine rule now, using sine rule, I'll be having sine A over small a, that is sine A over small a, equal to sine B over small b, that is sine B over small b, equal to sine C over small c, that is sine C over small c. Okay. Alright, so we'll then look at that. Means that sine angle at A is 50 degrees. Angle at A is 50. This angle here, angle 50. That's the angle at A. That's sine 50 degrees. This is sine 50 degrees over, and small a is tension T1. Tension T1 equals to sine angle at B is 100 degrees. That is sine 100 degrees over small b is the weight 20 Newton. So I'll take my 20 Newton weight, and then I'll have is equal to sine C. Angle at C is this 30 degrees. Not this one is outside, so this 30 degrees. Angle at C, that's sine 30 over small c is tension T2. So what then do you do? We'll compare this to this, and secondly we'll compare this to this. So let's do the comparison now. This is sine 50 degrees over tension T1 equals to sine 100 degrees over 20. Okay, so then I can cross multiply. By cross multiplication, I'll have T1 sine 100 equals to 20 sine 50 degrees. Okay, and then I can make T1 subject of formula. When I divide both sides by sine 100, we're having T1 sine 100 degrees divided by sine 100 equals to 20 sine 50 degrees divided by sine 100. Okay, so this will eliminate this, and my tension T1 will be equal to, say T1 will be equals to 20 sine 50 degrees divided by sine 100. Okay, divided by sine 100. So means that T1 will be equals to 20 times sine 50. We'll look for that with our scientific calculator. Sine 50 is 0.766 over sine 100 will give us 0.985. Okay, so that means that T1 will be equal to, when I multiply 20 times 0.766, this will be 15.32 divided by 0.985. My tension T1 will be equal to, this will give me 15.55 Newton. Okay, that's my tension T1, 15.55 Newton. This is approximately 15.6 to 1 decimal place. Okay, so T1 is approximately 15.6 Newton to 1 decimal place. Okay, then let's compare this second one. Find T2, compare this and this. That's sine 100. This will be sine 100 degrees over 20 will be equals to sine 30 degrees over T2. Okay, but then cross multiply. Now we have T2 sine 100, that's when I cross multiply, equals to 20 sine 30 degrees. Okay, that is, this will multiply this at 20 sine 30, T2 will multiply this, T2 sine 100. Okay, then I divide by the coefficient of T2, which is sine 100. Now we're having that T2 sine 100 divided by sine 100 will be equals to 20 sine 30 divided by sine 100. Okay, so this will eliminate this, and T2 will be equals to 20 sine 30 degrees divided by sine 100. Okay, alright, so sine 30 is 0.5, so T2 will be equals to 20 times 0.5 divided by sine 100 is 0.985. So this now will be 20 times 0.5 is 10 divided by 0.985. So that's 10 divided by 0.985 will be, this will give you T2 as 10.15 Newton. Okay, that's tension T2, and tension T1 is 10.6 Newton. Alright, okay, so that is it. We'll stop there. Those are the tension in the two forces. Tension T2 is this, tension T1 is this. Alright, we have another question on the board. The question says the picture of weight 4 Newton is supported by a string on a nail as shown in the figure below. Find the tension on the strings at A and B if the strings are each inclined at 70 degrees to the vertical. So these are the strings inclined at 70 degrees to the vertical. This is the vertical, 70 degrees to the vertical, and the weight of this picture is 4 Newton. Okay, so we are going to draw the triangle of forces. So let's do that quickly. Now you must know that if this is 70 degrees, 90 minus 70 here will be here we give you 20 degrees. You should know that. And then here is also 20 degrees. Okay, that is it. That's you add it, everything is 90 degrees. So that is it. So everything here is 90. That will be 70 plus 20 is 90 degrees. Okay, alright, that's it by the way. take this weight first, take the weight acting vertically down. So taking the weight that is acting vertically downwards, you have this, the weight that acts vertically downwards, that's W equals to 4 Newton. Then the next thing I'll take there, I'll go back, I'll take this tension force going this way, which is inclined at 70 degrees. So I'll take tension force going like this. Take my tension force going this way, and it is inclined at 70 degrees to the vertical. Means that this side will be 20. Okay, this is my tension force T. So I'll come back again to that diagram. Okay, I'll take this other tension force going this way. Okay, take this one going like this, and you must know that for this, if this is 20 degrees, this is 20 degrees, then that means here is also 20. So this will alternate here as 20 degrees, and then drawing something downwards like this, this will alternate this side as 70 degrees. Okay, so this is alternate to this, 20 degrees is alternate to 20 here, and 70 is alternate to 70 degrees here. Abi? Yeah, so I can then take that quickly. That's take this line going like this and take the angle. That would be so I took my tension force there. Tension force T at an angle of the angle is 70 degrees with the vertical. Okay, so I have that. Okay, so the first thing I took was the weight acting vertically downwards. Then I took the other tension force going this way, which is inclined at 70 degrees. The tension force, I took this one, inclined at 70 degrees to the vertical. And then later I took this other one, took this other tension force, and this angle is also 70 degrees with respect to the vertical line. Of them tip to tail, tip to tail, tip to tail. Okay, so this is the tip of it, and carry the tail of this, join it. The tip, carry the tail of this one here, join it. Tip to tail, tip to tail. Alright, so if this is A, let's assume that this point is A, this point is B, and this point is C. Alright, so we'll solve that. If that's capital C, here will be small c, capital A, here will be small a, capital B, here will be small b. Alright, so let's solve that quickly. Now we should know that this 70 degrees, let's look at this. Take a line like this, and you see that 20 degrees will alternate here as 20, isn't it? That's 20, this is alternate to this, and 70 will alternate here. 70 degrees will alternate outside 70. Right? So that is it. Then you come here as well. This taking a straight line, straight horizontal line. See this angle here, 90 minus 70 is this will be 20 degrees, and this will alternate here. This angle is alternate to this angle. Okay, 20 degrees is alternate to 20 degrees here. So I then add the two of them. I'm adding the two angles. 20 plus 20 gives me 40 degrees. Okay, that's 40 degrees. So I have that. Now you use sine rule. Using sine rule to solve. Say using sine rule. Using sine rule. Using sine rule. So using sine rule, that is sine A over small a equal to sine B over small b is equal to sine C over small c. Okay, an angle at A is 70 degrees, so that's sine 70 over small a is tension T. This is my tension T. Is equals to sine angle at B. Angle at B is 40 degrees. That's sine 40 degrees over small b. Small b is the weight, 4 Newton. This is 4 Newton. Is equals to sine C. Angle at C is 70 degrees. That's sine 70. And small c is also tension T. Tension T. Okay. Alright, so I'm having this sine 70 over T equals to sine 40 over 4. Okay. Now you see that these two are similar. Both are similar. So just take one of them, then compare it with this. So I'm saying my comparison now is sine 70 degrees over T is equal to sine 40 degrees over 4. If I cross multiply, I will have this times this is T sine 40 degrees equals to 4 times this one is 4 sine 70 degrees. Okay, so divide by the coefficient of T. This is T sine 40 divided by sine 40 equals to 4 sine 70 divided by sine 40 degrees. So this we cancel out this, and I'll have that T is equals to 4 sine 70. Tension T is 4 sine 70 degrees divided by sine 40 by sine 40 degrees. Okay, so I'll look for sine 70. So this is equals to 4 times 0.9397 divided by sine 40, which is 0.6428. Okay, so I'll multiply 4 times 0.9397. I multiply this now, I'll have 3.7588 divided by 0.6428. Okay, so when I divide this now, this will give me 5.85 Newton. So therefore the tension T in the rope is 5.85 Newton. Alright, so take note of that. The tension in the rope is 5.85 Newton, and we found out using the triangle of forces. We have gotten the value of T. Tension in the rope has been gotten as 5.85 Newton. Okay. Alright, we have the third question on the board. It says a rope 5 meter long is fastened to 2 hooks 4 meter apart on a horizontal ceiling. So we'll first draw the horizontal ceiling. And I'm having something like this. This is the horizontal ceiling, and then they say there are 2 hooks. Let's say this is the first hook, and then we'll take the second hook, and then they said the hooks are 4 meter, fastened to 2 hooks 4 meter apart, 4.0 meter apart. So that means that the distance between these 2 hooks, the distance between the two hooks is 4 meter. That is the distance between the both hooks. Distance between the both hooks is 4 meter. Okay. Then I said the rope is attached to a 10 kg mass, so that the segments of the rope are 3 meter and 2.0 meter. So this is the rope actually. This is that rope. And then I placed a mass on this. Rope. Of course, because of the mass, you see that because of this mass here, you observe that this rope will go in 2 directions. That is, it will sag, and by sagging we have something like this. This was the initial position of the rope, but because of the mass applied, it will sag in these two directions. Okay, so I'm having this. Alright, so I have something like this. And then we are told to compute the tension in each segment. Tension in each segment now, that is tension T1 and tension T2. Okay, now this will actually have a weight. This mass will have a weight which will act vertically downwards, and I'll say that my weight W is equals to mg, and W will be equal to the mass of that body. If you look at this, it's a 10 kg mass, 10 kilogram mass. So the mass is 10 kg. This is 10 kilogram multiplied by acceleration due to gravity is 10 meters per second square. So 10 times 10, my weight now will be equals to 100 Newton. Okay, the weight is 100 Newton. All right, and then we also look at this. They said so that the segments of the rope are 3 meter and 2 meter. Okay, so that means that we can take this one as 3 meter. The length of this one, you can take it as 3 meter. Length of this side of the rope is 3 meter. It's 3 meter, and the length of this other side is 2 meters. Okay, it's 2 meters. Okay, so this is 2 meter and this is 3 meter. You know that when you add them, 3 plus 2 will give you 5. That is the actual length of this rope. The rope is 5 meter long. So when you add them now, that's 3 meter plus 2 meter gives you 5 meters. Alright, so what I'll do now is to cut out this section and solve. Then I'll cut out this other section and solve as well. So I can call this angle here, call this angle alpha, then call this other angle theta. Alright, okay, so I'll cut that section out and I'll have something like this. You should know that this is 90 degrees. This is angle 90 as well. So I'll cut this section out. I'll have, if I cut it out now, I'm having something like this. Okay, so the length here is 3 meters, and then this angle here is alpha. Alright, here is 90 degrees. Now we'll look for this side, this length here. Distance between the two hooks, the distance between the two hooks is 4 meters. And when we section this now, at equal distance, sectioning this, half of 4 is 2. So it means that this is 2 meters, and this is also 2 meters. Okay, so half of 4, sectioning this, half of 4 is 2. This is 2 meters, this is 2 meters. Okay, alright, so I'll be taking that. I'll take this as 2 meters. Okay, so the side now that faces this angle of inclination is my opposite side. Call this my opposite side because this is a right angle triangle, and the longest side facing 90 degrees is the hypotenuse. The remaining side becomes my adjacent. So I'll go back to my trigonometric ratio. So go back to the trig ratios. Now since I'm giving the hypotenuse and the opposite, I will make use of so. I'll make use of this. Make use of so. It means that sine alpha will be opposite over hypotenuse. So sine alpha, my opposite side is 2. That's 2. My hypotenuse is 3. Over 3, okay? So sine alpha equals to 2 divided by 3 will give me, so 2 divided by 3 will give me 0.667. Okay? And I'll look for the sine inverse. I say that alpha is equals to sine inverse of 0.667. And that alpha will be equivalent to, this will give you 41.84 degrees. So I've gotten the value of alpha, I can take it to the nearest whole number. To the nearest whole number, I say that alpha is approximately 42 degrees. That's when I approximate to the nearest whole number. Taking this one now, put here, that's 42 degrees, okay? Then I'll take the next triangle. This is the next triangle. I'll cut this triangle out, solve, so that I can get the value of theta, okay? I'll cut out this triangle, solve, and get the value of theta. This is 2 meters, this is 2 meters as well. So let's do that quickly. So if I cut it out now, I'll have something like this. Alright, this is 90 degrees, and this angle here is theta. Okay, so I'll call here 2 meters, that is 2 meters here, and over here is also 2 meters. It's also 2 meters, okay? Now, the side that faces angle 90 is my hypotenuse side. This is the angle of inclination, and the side facing the angle of inclination is my opposite. Okay, the remaining side becomes the adjacent. Alright, so we have the opposite and the hypotenuse. So that is sine theta is equals to opposite side over the hypotenuse. Okay, so it means that sine theta equals to opposite is 2. And hypotenuse is 2. So 2 divided by 2 will give me 1. So it means that sine theta is equals to 1. And theta will be the sine inverse of 1. Means that theta is 90 degrees. Theta is equals to 90 degrees. So we have gotten these angles as 90. Here is 90. And we add here as 42 degrees. Okay. Okay, so we have gotten here. This is 42 degrees. And we add here as 90. Okay, so we can then draw the triangle of forces. First, I'll take the weight that is acting vertically downwards. Take the weight acting vertically downwards. That weight is 100 Newton. That weight, taking the weight acting vertically downwards, I'll have something like this. And W is 100 Newton, which acts vertically downwards. And then I'll come back again. I will then take this tension force going this way. Tension force going this way, inclined at 90 degrees. So that will be, take my tension force going like this. Tension T2. Angle is 90 degrees with respect to the vertical, the 90. Okay, then I'll take tension T1 going like this. And then you should know if here is 42 degrees, 90 minus 42 will give, so this angle is 48 degrees. 48 degrees. Why this other one now? 90 minus 90 is 0. Here is 0 degrees. Okay, so this is 48. I'll take this tension force, then take the angles as well. Okay, let's come back to this quickly before we proceed. This will alternate. 48 will alternate here as 48 degrees to alternate here, and 42 will alternate this other side. 42 degrees will alternate here. Okay, so this is alternate to this, while this one is alternate to this one. Okay, so we can then take this section out. So if I take that section out, I will extend it here. Okay, call this T1, and if you observe that angle at this point is 42 degrees. So I'll take it and I incline it there, 42 degrees. Okay, so that is it. Alright, so you can use dotted lines, do this. Also use dotted lines here, indicate here. Okay, so here now will be what? 48, because 90 minus 42, this is 48. these two are complementary angles, and use dotted lines here. This is 0. Okay, so 0 will alternate here, 0 degrees. Then if I use dotted lines as well here, 90 will alternate here as 90 degrees. And then we also observe that what's it called, this other one, 48 degrees will alternate here as 48. This is 48 degrees, alternate angles. It's also 48 degrees. Okay, so I'll add them. 48 plus 48 gives me 48. So this is alternate to this, and this side is alternate 42 will be alternate to this 42 here. Okay, so this is alternate to this, and this is alternate to this one. Okay, and then you also see that 90 is alternate. 90 is alternate to 90. 0 is alternate to 0 degrees here. Then I add them, I have 48 degrees. So I can call this point A, call here point A, call here point B, and call here point C. Alright, so quickly we use sine rule. If here is capital A, the side facing it will be small a, and then if here is capital B, side facing it is small b. Capital C, the side facing it will be small c. Alright, so quickly let's do that. Like I say, using sine rule, I'll be having, so using sine rule, so I have sine A over small a is equals to sine B over small b is equals to sine C over small c. Okay, so sine A over small a equals to sine B over small b equals to sine C over small c. So angle at A is 90 degrees, so this is sine 90 degrees over small a is tension T1. Okay, T1 equal to sine, angle at B is 48 degrees, that's angle at point B, 48 degrees, that's sine 48 degrees, and small b is 100 Newton, that is the weight of the body, 100 Newton. Then that will be sine, angle at C is 42 degrees, sine 42 degrees, and small c is tension T2, okay, so angle at C is 42 degrees, small c is tension T2. Now compare the both of them, compare this to this, then compare this to this. I can get T2, T1 and then T2. So by comparison now, I have sine 90 degrees over tension T1 is equals to sine 48 degrees over 100. Okay, so I cross multiply this two times this one times this, that's T1 sine 48 degrees is equals to 100 sine 90 degrees. Okay, I divide by the coefficient of T1. This coefficient is sine 48. So if I divide by the coefficient of T1, I'll be having T1 sine 48 degrees divided by sine 48 degrees is equal to 100 sine 90 degrees divided by sine 48 degrees. So this we cancel out this. Now that T1 is equals to 100 sine 90 over sine 48. So we have that T1 will be equals to 100 sine 90 degrees over sine 48 degrees. Okay, and sine 90 is 1. This is 100 times 1 divided by sine 40. Sine 48 is 0.743. Okay, so T1, tension T1 will be equals to 100 times 1 is 100 divided by 0.743. So when I divide it now, I'll be having 134.58 Newton. Okay, so I will approximate this. That's T1 is approximately 134.6 Newton to one decimal place. Alright, now let's get that of T2. We'll still come back again to this equation. We'll compare this to this. Compare this to this one. That will be sine 48 over 100 equal to, okay, that is sine 48 over 100 equal to sine 42 degrees over T2. Okay, so that is it. Now then cross multiply, and by cross multiplication this will multiply this. This is T2 sine 48 degrees, and this will multiply this one, equals to 100 sine 42 degrees. Okay, so I divide by the coefficient of T2, which is sine 48. I have T2 sine 48 degrees divided by sine 48 equals to 100 sine 42 degrees sine 42 degrees divided by sine 48. Okay, so this will eliminate this, and I have that T2 is equal to, the tension T2 will be 100 sine 42 degrees over sine 48, or sine 48 degrees. Okay, and sine 42, we'll find the value of sine 42. This is 100 multiplied by sine 42. So sine 42 is 0.6691, okay, over sine 48. Using your scientific calculator, you will get, that's 0.743, okay, that's 0.7431. Then if I multiply now 100 times 0.6691, this will give me as T2 equals to 66.91 divided by 0.7431, and my tension T2 will be equal to, when I divide this, I'll be having 90.04 Newton. Okay, that's the tension T2. And we had tension T1. Tension T1 has 134.6 Newton, or 134.58 Newton to 2 decimal places. Okay, so that is it. Okay, so take note of everything we have done. This is T2, 90.04, and T1 is this. This is a diagram showing you the triangle of forces. Okay, alright, showing the triangle of forces. Alright, and then this was the actual diagram, the two hooks. Okay, so we have tension T1, we have solved that of T1, and we had T1 as 134.6 Newton. Then we had T2, tension T2, as 90.04 Newton. Alright, thank you very much. Thank you.